My Android app now has all the code that's needed to display the current location when the user requests it, but it's also possible to set up a recurring location check that reports to the app when the location changes, using something called a location listener. I'm working in a version of the project now called Location Listener, and I'm going to start by adding code to the onConnected method. This is the method that was implemented in the earlier exercise when I set up a couple of interfaces in this class. The onConnected method tells you, I have a connection to the location service. Now, how do you want to use it? There's a class called LocationRequest that lets you package up all the information you need to describe how you want to use the service. You can set a priority, say on highest accuracy or lowest cost, and you can set and control the intervals. I'll place the cursor after the toast message and add a few more lines of code. First, I'll create an instance of that LocationRequest class. I'll name it Request, and I'll instantiate it using a method of the LocationRequest class called create. Next, I'll call a few of the request object's methods. First, I'll call one called setPriority. The LocationRequest class has a number of constants, and you can choose options like high accuracy, no power, balancing power and accuracy, and so on. I'll choose high accuracy because this will give me the most frequent reports of location changes. Next, I'll call a method called setInterval. You set this value in milliseconds, and so that I can see what's happening, I'll pass in 5,000. Meaning redo the request every 5 seconds. Now, be cautious with this. An app that's making a request to the location service every 5 seconds might end up sucking up a lot of battery power, and so you should be conservative with this. In fact, Google recommends that for a production application, you consider looking for the newest location every minute, and that would be 60,000. But again, for this demo, I want to see the request in action, so I'll use a small value of 5,000. And finally, I'll call a method called setFastestInterval and pass in a value of 1,000. And now it's time to make the request. I'll use the location client object that was created earlier, and I'll call a method called requestLocationUpdates. I'll pass in the request object, and I'm asked for a listener object, a class that will listen for events that occur. I'm going to pass in this, meaning the current class, this main activity, will implement all the methods that are needed to react to the events. When I save my changes, I see an error over on the left. I'll click it, and I'll choose the second quick fix to let the main activity implement the class LocationListener. When I double-click on the quick fix, that adds LocationListener to the list of implemented interfaces. Notice that this interface is a member of the package gms.location. There's an older version of the location or listener class that's a part of another package. Make sure you're implementing the right one. Now, I've said my main activity class is implementing location listener, and I need to add the required methods. So I'll click the error icon and choose Add Unimplemented Methods, double-clicking, and I'll scroll back down to the bottom of the code, and I'll find one new method, onLocationChanged. The older version of the location listener class had 4 different methods. You don't need them. All you need is this one method, onLocationChanged, and when it's called, it'll pass in a new location object. I'm going to change the name of the argument, that's the location object that's passed in, to simply location. And then I'll create a string variable called message that will be constructed from a literal string of location, and then I'll append to that the latitude and longitude, using location.getLatitude and location.getLongitude, and I'll separate them with a comma. Then I'll output a toast message. And for this demonstration, that's all I'll do. My goal here is simply to show you that you're getting the information. What you do with it is up to you. And once you know how to place markers on the screen, draw lines, and so on, you would be able to use this information to change the display in some way. I'll save my changes and run the application. And when the application first starts up, it shows me that I'm connected. And then as the application runs, it periodically shows me the current location. Now my device isn't moving at all, but the location changes are still being registered, and you'll see small differences in the values that are being reported. And that's because the way the location service works, it's making the request and evaluating its location each and every time. And perhaps the strength of the wireless routers that it's reading is changing in some small way, or the GPS satellites are sending back very small differences. Now again, you're seeing how often the changes are being reported. And in a real production application, this much activity might take up too much battery power. So be conservative in your use of this feature. And if you can make the duration a little bit longer, you'll end up preserving the battery power of the mobile device.